everyone, and welcome back to Brains Are Beautiful. In today's episode, we're going to be talking more about imaginary numbers. Now, if you don't know what an imaginary number is, or this is kind of a rough subject, you might want to go back to the intro video where we go over in depth about how imaginary numbers work and what they are. In this video, I'll just give you a quick refresher, and then we're going to go straight into complex numbers, what they are, graphing them, adding, multiplying, and then there'll be another video that does even more in depth on that. So here's our quick refresher. We learned last time that I is an imaginary number and it is equal to the square root of -1. And we did the examples of -16 square root and the square root of -20, I believe. And we went through this and we said this was -1 times 16, and we said this was -1 times 20. So we said this -1 times the square root of 16, this was 4i, and we said that this could be broken down further, -1 times 4 times 5, and we said this equaled the 2 square root of 5i. Okay, so those were our two answers from that. And then if we come down further, we went into some specific rules about imaginary numbers. We said I equals the square root of -1. We said I squared equals -1. We said I cubed equals the opposite of the square root of -1, which we said equal -I. And we said I to the fourth equals 1. And these were our major rules that basically repeated themselves over and over and over to infinity and beyond. So if we'd said I to the fifth, that equals the negative square root of 1, the square root of -1. We said I to the sixth equals -1, I to the seventh equals -I, and I to the eighth equals 1, and so on and so forth. We then did quite a few examples and really in-depth examples, but I'll redo one of them. I to the 99th. We said we could break this down. Instead of multiplying I 99 times, we could look for a multiple of 4, which we found was 96, and then we could add whatever was left over to give us 99, which in this case was 3. And so the reason we did this is we were looking for that multiple of 4, so that way we could basically just ignore that, because if you remember, I to the fourth equals 1, so this just all goes away. So all you're left with is I cubed. Okay, so that's it for our refresher course. If any of this didn't make sense or it was too fast for you, don't worry. Just go back to that other video, refresh really quick. It won't take you long, and then come back to this video. So for today's topic, we are going to be focusing on complex numbers. Okay, and all this is basically, it is just adding two numbers together is how you can think of it. So we are just adding two numbers. So the first type of number we're adding is a real number, and the second type of number we're adding is an imaginary number. And they come in the form of A plus BI, where A is our real number and B is our imaginary number. What's cool about this is actually either part can be 0 as well. And so a lot of times probably in homework, they will ask you to identify the real and imaginary parts of each number. So the best way to do this is just make a chart. And over here, we're going to put complex numbers that we're given. We're going to then identify the real part, and we're going to identify the imaginary part. So the complex number, let's just say we are given 5 plus 7i. So we need to identify the real part and the imaginary part. So the real part is the A component of that term, and the imaginary part is the B component of that term. So for what we're given of 5 plus 7i, the real component is 5, and the imaginary component is 7. Now say we're just given the number 8, because your textbooks are tricky and they'll do that to you sometimes. So how we could treat this is we still look at that a plus bi. And since there is no bi, the entire thing is real. So the real component is 8, and the imaginary component is 0, because there's no I term over here. So we can say this is real only. And then if we go a little bit further, say we're given, let me just erase that so I don't confuse you. Say we're just given negative 3i. Well, that's only that b term up here. So we have 0 for the real and negative 3 for the imaginary. So this is imaginary only. Okay, so now with that under our belt, let's go on to graphing. And sorry if this seems to be moving kind of fast. A lot of these topics are just very kind of scattered, and then they'll ask you to apply all of them at the end of your textbook. So I want to make sure that we are able to cover everything to help you guys succeed. Okay, so this is looking a lot like your x and y graphs, right, with your x and y axes. Well, it is similar, but we have a new axes now, and this is the real axis, and what used to be your y-axis is now your imaginary axis. Okay, and I think the best way to do this is just with examples. So say we have 2 plus 3i. Well, the 2 is the real and the 3 is the imaginary. So we can come over here to 2 on the real, and we can go up 3 for the imaginary. So 1, 2, 3. So this is 2 plus 3i. Let me switch colors and we'll do another example. So we want to graph negative 5 plus 4i. Well, we go on the real and then imaginary. So our real is going to be 1, 2, 3, 4, 5. There's a fifth one out here. And then we go up 4. So our point is going to be right here. And this is negative 5 because we went negative in the real axis direction. And then we went positive for the 4i. Okay, and then let's do one last example. Negative 3 minus 2i. So that's negative 3 on the real axis and negative 2 on the imaginary axis. So we go over on the real 1, 2, 3, and we go down 2, 1, 2, and there is negative 3 minus 2i. Okay, so now let's go into the rules of addition for the complex numbers. And again, I just think it's the most easy to explain through an example. So let's just jump right into 2 plus 3i. And let's add to it 1 plus 8i. So all that we do, the first step is we add the real numbers. It's a pound sign. And the second step is we add the imaginary numbers. Okay, and let's do that. So then we have 2 plus 1 plus 3i plus 8i. So 2 plus 1 is 3 plus 3i plus 8i is 11i. And that's our answer. Let's do another example. Let's say we have 4 plus 6i plus negative 3 minus 7i. Okay, so remember first we do the real numbers, then we do the imaginary numbers. So if we take these, we can go 4 plus, we have a negative 3 plus 6i plus a negative 7i. So yeah, just carry the subtraction, those negative number signs with those terms and should be good to go. So 4 plus a negative 3, that's the same thing as 4 minus 3. So you have 1, and you have 6i plus a negative 7i. That's the same thing as 6i minus 7i, which 6 minus 7 is negative 1i. So that equals 1 minus I. And that's the answer. So now let's say just to go a little bit more in depth, I think we'll do this probably more in the next video, but let's say that we want to do a graphic representation of this. So we would draw our axes, and we have real where the x used to be, and we have imaginary where the y used to be. It's really bad writing, sorry guys. And what we do is we're going to graph this first, and then we're going to graph this attached to that term. And I'll show you what I mean. So if we go over 2, 1, 2, because that's the real part, and then we go up 3, because that's the imaginary part, we get 2 up 3i. So we can draw a vector. A vector is an arrow. It has magnitude and direction. That's a little bit probably advanced for this class, but it'll come back in other classes, so might as well introduce it now. But so we can basically draw an arrow up to that point, okay? And then what we do is we know we want to add to that value this 1 plus ai. So what we can do is we go, okay, so how much more in the x direction or the real direction is that? That's just 1 more. And we know how much more in the imaginary is 8 more. So then we can go over 1, up 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to draw our arrow going to there. And so let's just label our work as we go. We know that this was 2 plus 3i, and we know that this line up to this dot was 1 plus 8i. So now what we can do is we can draw the resulting vector. Okay, I know those are big words. So it's basically the arrow that goes from the very beginning of the problem to the very last dot of the problem. And this is your 3 plus 11i, which is the answer we got right here. So now let's move over to multiplication. So for multiplication, we are going to use the old standby of FOIL. There's quite a few fancy methods out there, and really what it all boils down to is FOIL. They skip a bunch of steps, and basically they make you memorize a bunch of rules, but if you know FOIL, you can do any sort of these multiplication problems. And so I find it easiest to have a bunch of tools in my belt, but especially one that I'm really comfortable using that I can pull out at any time and it will do the job. So I'm going to use variables first just to show it, and then we'll go into a couple examples. So we have a plus bi times c plus di. And so FOIL states first, outside, inside, last. Remember, it's based off of that distributive property. Okay, so if we actually do this, we're going to get a times c, which is ac, plus the outside, which is a times di, plus the inside, which is bic, plus the last, which is bidi. So if we just kind of simplify a little bit, AC plus ADI plus BCI plus BDII, which is I squared. So if we really wanted to go even a little bit further, we could show it like this. Now you could technically just memorize this and then plug the numbers corresponding to those letters in. If that's the easiest way for you, then that's fine. But to me, I just like to start from scratch each time. And if you notice, just maybe this will make it easier. This is kind of like when you were originally learning the quadratic formula. And I think you had, say, like we had ax squared plus bx plus c. Well, if you could notice that your i's are actually kind of in the same spots that the x's are. So, food for thought. Okay, so let's do an example. Say we are given the two complex numbers of 2 plus 3i and 5 plus 4i. and we need to simplify, multiply them out. Okay, so let's remember FOIL, and let's go for it. So we're going to go here, then here, then here, and finally there. So 2 times 5 is 10, plus 2 times 4i is 8i, plus 3 times 5 is 15i, plus 3 times 4 is 12, I times I is I squared. Okay, and so if we simplify that further, we can say 10 plus 8i plus 15i minus 12. And the reason is, if you remember our rules, I squared equals -1. So we could plug this -1 in for I squared, which makes it this negative right here. And now we can use our rules from the addition that we just did a few minutes ago, and we know to add all the reals together and then all the complex together. So we can say that 10 minus 12 is -2, and we can say 8 plus 15 is 23i. And then let's just do one more example really quick. X equals 2 plus I quantity squared. So we know this is the same thing as 2 plus I times 2 plus I. Let's use FOIL. So we're going to go 4 plus 2I plus 2I plus I squared. So if we simplify that down, that's 3 plus 4I. All right, everyone, thanks for watching, and if you have any questions, feel free to comment below. If this helped you, please like and subscribe to my channel. Also, please feel free to leave any suggestions for future videos you'd like to see or need help with. All right, thanks everybody, and remember, brains are beautiful.